I want you to concentrate on the slides because I'm going to be complimenting that. I'm not going to be reading what's on the slide. So as all of us know, global warming is happening. It's a silent epidemic, and it's causing a lot of problems, erratic weather patterns. And we all had the polar vortex, which hit in December and January. I had to pay a lot more electric bills because of that. So all of us know. So this graph is very important, and I put this because what this shows is from the past 400,000 years, tracing up, you can see the amount of carbon dioxide in the atmosphere, and can you see the spike? This has happened over the last 100 years. Now what I want to prove with this graph is, we are the cause for this. This happened when the Industrial Revolution started. And fossil fuels, we started consuming fossil fuels. So we are the cause for this. So we have to find a solution for it. And a lot of erratic weather patterns are happening, and tsunamis, earthquakes, chilly winters, really hot summers. And our planet is really trying to tell us something. You know, it's kind of hurt, but we're not actually listening. And the event horizon for global warming is predicted to be around 2024. And if we start to act now, the changes might be reversible. But after this, 2024, we can't really do anything. It's all over. So this started when I was doing my undergraduate back in India. And I was watching a video of Vice President Al Gore. It was a 2-hour-long video on YouTube, and that got me thinking. You know, he was talking about a lot of alarming facts like these, a lot more facts. And that really got me thinking as an engineer, as a computer science engineer, what can I do to save the environment? And I was working on RFID, stands for radio frequency identification, which all of you have in your Comet cards. So I was working on that, and it got me thinking, and I tried to study environmental policies and environmental engineering, and I concluded and realized that the core fundamental idea of solving this problem is this: reducing the carbon footprint of processes. Now, this is the main idea. So for many of you who know what carbon footprint is, that's awesome, but many of you who might see this video on their laptops, they might not know what carbon footprint means, so I'll give you a quick introduction to it. So let's say you go to Walmart and buy groceries. You go buy onions, tomatoes, milk, eggs, breads, your weekly stuff, and what you don't realize is, where are those materials coming from? Somebody's growing them somewhere in some other different state, and he's using his resources and money, and that's being transported to the nearest Walmart chain, and that uses fossil fuels. And now you're going and buying it, and that's probably going to serve probably 3 or 4 meals. Now the amount of energy which is going into that is a lot, but it's hardly serving 2 or 3 meals. But just imagine if you could grow the same thing in your backyard. As you know, Caitlin also said, yeah, you know, just grow it in your backyard. Saves energy. So coming back to this, sorry. So what I'm trying to say is the carbon footprint for this is 10 times higher than this. So now you understand what carbon footprint is and what carbon processes means. So I also realized that the core fundamental approach is, you know, reducing carbon credit and everything. And I call this the bottom-up approach. And help each individual reduce his or own carbon credit from day to day, and automatically the overall carbon footprint decreases of the entire system. And that's exactly what I'm doing here at TEDxUTD. I'm helping you people realize what carbon footprint is. And that's what I believe in. This is the bottom-up approach. Teach each and every individual, and if they try to rectify their lifestyle, automatically the system takes care of itself. So how do we do this? So what did I do as an engineer? I used RFIDs. I'm not going to go into too much technical. I'll keep it as simple as possible. I put RFIDs on 3 students. They're my friends, and I took their help. And so I tracked them for a month. I put sensors all around college. It was fun, you know. And we got a lot of data from it in a month. Then we looked at the data. We used little statistics and data analytics. We were getting introduced to data analytics back in the undergrad days. And we saw the data. We tried to make sense of the data. And we gave them the data back, and we told them, look, you're doing this right, you're doing this wrong, and we came up with our own processes and algorithms to do that. And this is what happened. By the way, this is the prototype what we did, just for the computer guys who's watching this. I use Java programming on Linux environment, so it's all open source. So this is what happened. This was before tracking and this was after tracking. As you can see, I'll just give you a quick review of this. This is the fossil fuel usage of these 3 students. And after a month when we gave back the data, look, they said, if you can cycle more, it's going to be helpful. So they started cycling more. And as you can see, this third guy, he started cycling a lot because we told him we'll give incentives, and he started feeling more hungry, so he started going to the canteen a lot more. So we concluded that based on this simple approach, this is a sequential approach, we could increase their efficiency by 40% on a day-to-day basis, and just imagine scaling this up to 20,000 people. So yes, I'm actually trying to do that here at UTD, and taking the idea further. RFIDs are old, they're not new, it's over, that technology has already come and gone. What we're trying to do now at the multi-agent labs here is we're using artificial intelligence and multi-agent systems to make buildings smarter. We're trying to put intelligence into buildings. And agents, now if some of this seems a little complex, don't worry about it, just go with the flow. In simple terms, agents are software robots. They have little intelligence in them. We put intelligence into them. We give them the code. And a little of reasoning and logic and communicating between other agents. And why we use this system? Because whenever it's decentralized. So there is nothing like a central server. There's nothing like a central server for this. Everything is a part of everything. And we don't have a central viewpoint. And the main idea of these multi-agent system is cooperation and agreement and communication. You'll understand about this in further slides. And these are some of the research projects we are doing at the lab. And my project is the agent-based smart campus. And this is what the purpose of my project is finally. I want to use agent technologies to improve the quality of life of UTDers and to make our campus energy efficient. And my goal is to make UTD the #1 energy efficient campus in the United States. And yes, it's possible, it's very much possible. And this is something what we did. We have a working prototype of this. It's called Comet Nav. In your cell phone, there's a small agent. So whenever you enter the engineering building, it automatically detects you, picks up your unique ID, goes to the database, retrieves your name, your Comet ID, and it says, welcome to ECS building. It will give you a list of classes you have today, and it will tell you if they're on schedule or not, how many students are there in class, and if you're coming to the engineering building for the first time, and if you want to go meet a professor, you just put in the details, and it will navigate you to the professor's room. So also tell you if the professor is there or not, and many things like that, basically to make your life easier. And this is what we're trying to build. This is not done. We're working on it. It's called Comet Park. As soon as you enter UTD campus, using GPS and networking technologies, I know parking is a big problem. I know many of, see, that's exactly what I'm talking about. And you enter UTD campus, so you just put in the details of where you want to go, engineering, Green Hall, ATech, and it's going to automatically give you the nearest parking spot and direct you to that. So ultimately, this is what we plan to do. We want to have agents everywhere. Like right now, all of us are sitting here and nobody's there in the hall, right? And so what this system will probably do is it will increase the AC output here and dim the lights there. So that's what we're looking at, smart buildings, smart technologies to save the environment. And that's exactly what I was talking about, This is just an example, 3 buildings are connected, and let's say there is an event going on in ECS North, and all the students from ATech and South automatically go to North. So agents in the building and their cell phones automatically track them with real-time analysis. And the air conditioning and the lighting to these 2 buildings will automatically be reduced, and the output will be given to ECS North, thereby, reducing the carbon footprint of buildings. And this is very much possible. This is not the future, guys. This is very much the present. Some industry implementations to show you that this is actually going on. IBM is doing a lot of work on smarter planet. You can Google it. They're doing wonderful projects in that. And recently, Google bought out Nest. Nest also works on similar things. When it manages your power consumption in your home, your air conditioning. It's basically a thermostat. And they're also building similar smarter systems to help save the environment. So I want to end this talk by giving you a small assignment and a few points. Simple points I want to spread to you so that you do your part in saving the environment. Download the Carbon Calculator app from the Play Store or the App Store. You're buying something off Amazon or something, or you go to Target, it'll probably take 30 seconds to check the carbon footprint of it. Just check it, and if it's too much, choose for an alternative and choose something which has a less carbon footprint. You might not be doing a favor right now, but you'll be helping your children and their children, trust me. And opt for hybrid cars. And I think my uncle bought a recent Toyota Camry. That's a hybrid. So I'm pretty sure that there are a lot of hybrid cars today in the market, and it's coming out. So if you're planning to buy a new car, just go for hybrid cars. And 883 bus service is beautiful. Use 883 bus service whenever possible, and carpool whenever possible. And I request all of you to be the change, because you have to lead. And only when you lead, only when you spread the word, will something happen. And that's exactly what I'm trying to do. And this is not my work. I'm just being the voice for what had to be done 10 years ago, which has not been done, unfortunately. And yes, coming to the homework, I have a small homework for all of you who are watching here, and probably for people who will be watching on their laptops. I showed you 3 points. Now what I want you to do is, for the next 48 hours, go implement at least one of them faithfully and share this video with 2 other people. And our planet is going to grade you. Earth is going to grade you. Nobody else is going to grade you. Do this for humanity. Do this for mankind. And do this for your children. And thanks for your time.